In this video, you will be introduced to a single beam and double beam spectrophotometer. This will include the component and working process of each instrument and how they differ to one another. So let's start with a single beam spectrophotometer. This picture shows you the example of single beam spectrophotometer. So this is the example of a single beam visible spectrophotometer available in the School of Chemical Sciences, University of Science Malaysia. If you can see here, it has only one sample holder, and you can put your cuvette with a sample inside into the sample holder. And if you can see in the display screen, this instrument can be operated using single wavelength only due to the use of radiation filter as a wavelength selector, thus limiting its capability to select more than one wavelength at the same time. For example, the wavelength that I choose for my sample is 650 nanometer. So the absorbance or percent transmittance of my sample can be obtained using this instrument. For this type of instrument, the source of light is tungsten halogen lamp and the detector is silicon photodiode. It is well suited for qualitative absorption measurements at a single wavelength and most often used for the visible region. As you can see in the diagram, this is the construction of a single beam instrument. The basic components of a single beam spectrophotometer are light source, filter, sample holder, and detector. Tungsten halogen lamp is commonly used as a light source. When the tungsten filament is heated, it starts emitting radiation in visible region. The radiation acts as a source of light for the instrument. The next component is the filter. It can be a basic absorption filter or interference filter. Next is sample holder. As I mentioned earlier, this type of instrument has one sample holder. The next component is detector. It can be a photoemissive cell or a photovoltaic cell. The detector gives reading of light intensity. Now, let us understand the working process of this instrument. It is required to take reading of the reference sample for calibration purpose. The light from the source falls on the solution placed in the cuvette containing reference or blend solution. In this solution, a part of light is absorbed and the remaining part is transmitted. This transmitted light falls on the detector, which produces photocurrent. This photocurrent enters the galvanometer. Next, the reference solution will be replaced with unknown sample and the same process will take place. And the concentration of unknown sample will be obtained. So now let's move on to the double beam spectrophotometer. This is the example of a real double beam spectrophotometer available in the School of Chemical Sciences, University of Science Malaysia. If you can see here, it has two sample holders. One for the sample solution and another one is for reference or blend solution. So it can be operated in UV and visible region in the range of 280 to 900 nanometer, and this instrument can be used for various type of analysis including photometric measurement, spectroscan, kinetic measurements and quantitative determination in clinical research and academic laboratories. In this diagram, the important components in a typical double beam spectrophotometer are light source, wavelength selector, multiple sample holders, and detectors. Other equally important components are optical components like collimating mirror and beam splitter. This type of instrument is known as double beam instrument because it passes two beams of light simultaneously. Now let's understand the working process of double beam spectrophotometer. The advantages using a double beam spectrophotometer is that the error due to the intensity radiation in source of light are eliminated. The monochromatic light exiting the grating assembly travels into different parts. One passes to reference sample or standard sample, and the other one passes to the analyte sample. Both of solution absorb part of light falling on them and transmit the remaining light. The transmitted light is detected by detector and reading is recorded. The concentration of analyte can be determined from the reading of the intensity. Generally, single and double beam spectrophotometer can be differentiated in terms of light source, instrumentation, and data quality. In terms of light source, single beam spectrophotometer uses a non-split light beam. In other words, all the light waves coming from the light source passes through the sample. In contrast, the double beam spectrophotometer uses a light beam that is split into two fractions before passing through the sample. One of the beam passes through the reference cell, while another one through the sample cell. In addition, a single beam spectrophotometer has a high throughput of light. A high throughput of light is desirable because more photons pass through the wavelength selector, giving a stronger signal with less background noise. However, in double beam spectrophotometer, it has low throughput of light, thus giving a weaker signal with more background noise. In terms of instrumentation, single beam spectrophotometer has a simple structure and requires less components. The components required are light source, filter, single sample compartment, detector, and readout unit. Meanwhile, a double beam spectrophotometer has a complex structure and requires more components compared to a single beam instrument. Including all components required to a single beam spectrophotometer, the double beam spectrophotometer requires monochromator, two sample compartments, mirrors, chopper or beam splitter or rotating disc, and many other additional components. In terms of data quality, the absorption measurement using single beam spectrophotometer is less reproducible because a single beam of light is used. Meanwhile, the measurement is highly reproducible using double beam spectrophotometer due to electronic and mechanical effects on both sample and reference beams are equal. In addition, single beam spectrophotometer gives less accurate result and has chances of error as blank solution and sample solution are operated separately. Meanwhile, double beam spectrophotometer gives more accurate and precise results because blank and sample are operated at a time. That's all for this video. Thanks for watching.